there's another technique we can use to simplify a complex fraction that might be a little bit easier. It's going to be easier for some complex fractions, harder for others. And the thing to keep in mind is that the usual rules for finding equivalent fractions still apply to complex fractions. And namely, the rule that I'm thinking of is we can always write an equivalent fraction by multiplying the numerator and denominator by the same thing. Remember, before, for example, we decided to write 2/3 with a denominator 12, and we decided to do that. We needed to multiply the denominator by 4, and so we should also multiply the numerator by 4. And so 2/3 was equal to 8/12. Right? This was a pair of equivalent fractions. How, you ask, does this help me in simplifying complex fractions? So one example might be if I have the complex fraction 5/2 over 7/2, I can multiply the numerator and denominator both by 2. Notice the 2's will cancel, and I'll be left with just 5/7. Just like writing equivalent ordinary fractions, we must multiply by the same thing. Of course, this example would be just as easy to simplify by dividing, right? 5/2 divided by 7/2 is 5/2 times 2/7 is 5 times 2 over 2 times 7. Again, the 2's cancel, and we get 5/7. So why do we bother developing this technique? We develop this technique to use with decimals. So let me show you an example of a complex fraction with decimals. We would like to choose a number to multiply the numerator 1.7 and the denominator 2.15 by in order to get an equivalent fraction where both the numerator and denominator are whole numbers. Right, so to make 1.7 a whole number, I think we want to move the decimal point one place to the right. To make 2.15 into a whole number, I think we want to move the decimal point not one, but 2 places to the right. Uh-oh. We want to do 2 different things here, don't we? Here we want to move it 1 place. Here we want to move it 2 places. But we have to multiply the numerator and denominator by the same thing. But wait a minute. If we have a whole number and we keep moving the decimal point to the right, it's going to stay a whole number, right? It's just going to have zeros on the end. So in fact, we want at least 1 place in the numerator, at least 2 places in the denominator. So we should pick the bigger one. We want to move the decimal point 2 places to the right. Right, so to do that multiplication, let's see. To move 2 places to the right, we want to multiply by a 1 followed by 2 zeros, I think. Let's see if that works. Notice, we're multiplying the numerator and denominator by the same things. Okay. Ignore the decimal points and multiply. I've got 17 times 100. That's 1700. 1 digit after the decimal point. Oh, good. I only have zeros after the decimal point. I'm going to be able to stop writing those. Down here, ignore the decimal point and multiply. I've got 21500. I want 2 digits after the decimal point. Again, I only have zeros after the decimal point. I'm going to be able to ignore those. So I get 170 215ths. And now, could I simplify this further as a fraction if I felt like it? Yeah, I see that these two have a common factor of 5, don't they? But we're not going to bother with that right now. You're welcome to if you'd like. Instead, I'm going to give you one of these to try. Just simplify to the point where the numerator and denominator are whole numbers, using this technique of multiplying the numerator and denominator by the same thing. Simplify 3.72 over 0.6 into an ordinary fraction. There's no need to write it in lowest terms, just for this example. Pause the video and try this now. All right, so here I want to move the decimal point 2 places to the right. Here I just want 1. 2 is bigger, so I'd like to multiply each by a 1 followed by 2 zeros. So now if you're comfortable doing this multiplication just by moving the decimal point, go for it. If you find that you often end up with the wrong number of zeros, use this method. Ignore the decimal points and multiply, and then we want 2 digits after the decimal point. Ignore the decimal points and multiply, and then we want 1 digit after the decimal point. So that's 372/60. Maybe you went ahead and simplified this. If you did, maybe you saw that 2 is a common factor right away. 60 is 2 times 30, of course. 372 is 2 times... I sure don't know off the top of my head. Shall we divide? Let's divide. 2 goes into 3 once. It goes into 17 8 times. It goes into 12 6 times. So we can cancel the common 2's. Looking at these again, you know, this 186 sure looks like a multiple of 6. Let's try and see if that really works. 6 goes into 1, not at all. It goes into 18 3 times. 6 goes into 6 1 time. Nothing left over. So yeah, that really did work. We've got 6 times 31 over 6 times 5. Cancel the 5's. Oh, now this is in lowest terms, right? Because 5 is prime and 5 doesn't go into 31. So if we continued to simplify this, we would get 31/5. For this exercise, it's fine to stop at this point, 372/60.